actually these 6 removals, they are not distributed within these 12 months. They are concentrated within these 3 months. And then next step, what we have to do? Okay, let's check historic data. So go back 1 year. Oh, what we have same story, same pattern, same removals. January 3, February 2, March 3, and then the next item 000. Again, using example, you can have some 1 here, for example, right? Is it enough? Let's go back 3rd year. Let's put here 3, 3, 3. Next is 0, 0, 0, 0, 0 again. Now, is it enough? As we can see, is when we have at least 5 items, right, repeating, we can say, hey, you know, now we can make decision. And suppose, based on this 12 months decision here, right, 2, 2, 2 means is, again, there is no big difference in numbers. Let's say, let's put here 2, right, or 3. Anyway, 2, right? And but when we take into consideration all these 2, the last year removals, the 2/3 year removals, the definitely answer is here. First of all, this is not correct, right? We agree, right? It's 0. It doesn't make any sense here. Until we have some specific type of formula when we take into consideration also all these 000s, when actually we don't have any removals. But definitely alert level is not 2 here, maybe 3 or 4. Let's put 3. Again, I'm not going now to detail level because, as I mentioned in the very beginning, I'm planning to create some interesting presentations, right? Operation reliability, task-oriented, and formula-oriented distributions. And I'm planning to create also how to calculate all these alert levels. And then probably I will include these seasonal removal alert levels in this presentation, okay? But I hope you understand the idea. Now, you can ask question, okay, what? We have to check back to 10 years? As I said, it depends, right? But average, based on my experience, maybe we need to check 10 years, but based on my experience, it can be, if we see the same story, same seasonal removals repeating 3, 5 times, in this case, 3, 5 years, right? We can say, hey, you know what? Okay, this is enough. Sometimes, you know what? 3 years is going to be enough. Sometimes even 5 years is not enough. But in this particular case, let's say 3, 5 years is enough. In your case, as I said, maybe, I don't know, 7, 6 years, whatever. Okay? Now we can ask question, what about if we don't have 2 years data and we just started operation January 1st this year? We are now in December. Very interesting question. In this case, I would recommend first to contact your manufacturer and ask the question to give you to send you original data you're operating, and you have enough information. And second, there are, as I said, very interesting formulas, distribution functions, especially small sample methodologies that you can use to calculate all this information. But before using all these distribution functions, theorems, equations, please understand all these items, adequacy, accuracy, representativeness from modeling side, and understand also to understand model checks, understand your distributions, your functions, your formulas from modeling side, theoretical side, and also we need to understand what's happening and how it works from operational / maintenance / business / experience side, from real life side. Because that's what we are trying. This historic data actually is from real life side. That's why we need all this historic data here. And then even when we understand it, and then we put this at we create some formulas, right? And we're gonna say, hey, you know what, this is the best function or whatever theorems we can use to solve this problem. Still, get the result. This is model check, as I put here, is continuous process, okay, non-stop. You have to check always. Finish the calculation, check result. Finish calculation, check result. Finish calculation, check result. Very simple example. Suppose, let's say 40 years ago, 40, right? We used the, let's go back, brake system, right? We have mechanical brakes. Landing gear, right? Mechanical brakes. And to do some analysis, what we use, let's say, get this example, we used some normal distribution, just example, or exponential, whatever you like, for some type of analysis. But nowadays, right, we're gonna see not only mechanical, but we have electromechanical brakes. And what does it mean? Maybe we need to change our functions, our distributions. Maybe we need to use Erlang distribution to be close to our real life analysis. Not the system is same, right? It's brake system, landing gear / brake system. But before we had mechanical brakes, now we have electromechanical. And let's say we have some to calculate, I don't know, some either removals or maintainability or whatever. And then since we change now, we actually change the characteristics of the system. And what does it mean? Is I said to be close to the real life. This is why we are doing this model in check, right? Model check, right? Because we want to be close to real life. We don't, when we say 500 flight hours, actually we mean 500 flight hours. Right? We don't want to start thinking, okay, this is 500 or 350 or 550. I hope you understand the idea, right? Even when we have, again, these numbers, we have to do all this continuous check. Are we done? Not yet. Always ask second opinion. When we finish our modeling here, right, everything is ready. We think, oh, now, you know what? We can publish it. Stop. We have to go to ask our colleagues, what do you think? And if our colleague finds this 0.1 and saves 100,000 or euros, right? Then definitely we have to tell our colleague, thank you very much for your support. Okay, are we done? Not yet. Final decision should be any of these 500, 2 removals, 3 removals, it doesn't matter. To use always engineering judgment. This is positive norm. Don't forget, please don't ignore this advice. Always use engineering judgment before finally you say, oh, this is 500 flight hours, or alert level is 303. Okay, now let's move to the part 2 and see some interesting distribution functions, theorems, equations to analyze our operational reliability. All these items are here based on my personal experience, or I've seen other people were doing solving some interesting tasks, or I read in the reliability engineering books, starting from my civil aviation university years. Okay. By the way, all items are in alphabetical order. Okay, let's start from A first group, which is function properties parameters. We have here confidence interval, confidence level, correlation. You're going to have 0 or negative, positive, right? Chebyshev's inequality, divergence, entropy, expected value. We can use it to calculate parts, likelihood, mean, median, mode, moment, percentile. All these items are from basic stats, right? Quantile range, skewness, standard deviation, variance, z-score, etc., etc. Group number 2, statistical distribution theorems, bias or conditional distributions, beta distribution, binomial, chi-square or xi-square if you use Greek word, Erlang distribution, exponential, gamma, Gaussian or normal, geometric, logarithmic, Laplace, Lagrange, Poisson, Rayleigh, uniform, rectangular, Weibull, etc., etc. Group number 3, theories, rules, others, evaluating indeterminate forms, L'Hopital's rule. Second, renewal theorems, Blackwell type renewal theorem, Walter-Smith theorem, Waltz equation. Number 3, sample testing, hypothesis test, Mann, Whitney, Wilcoxon type test for 2 samples. I think this item is here in Microsoft Excel, the formulas and the functions, right? List. Others, Queen theories, Markov's process, Markov chains. We had a lot of discussions about this part. Small sample methodologies, etc., etc. 2 words about small sample methodologies, right? If we open our classical mathematical statistical books, right, they tell us that we need to use all these distribution functions theorems, right? At least 30 samples. In our case, 30 removals, 30. And unfortunately, I'm not talking here now about this low reliability LRUs, right? But if we just have, we just started company, we need 3-5 years to have these 30 removals, right? And we don't have these 3-5 years. Sometimes we need to analyze the LRUs when we have 3, 4, 5 removals. That's where all these small sample methodologies are just working perfectly. But again, as I mentioned, right, please understand, first of all, understand what's happening from your real life side, experience side, and then you need to understand how to use all these small sample methodologies, all these formulas, distributions, functions. There are a lot of mathematical statistical websites, right? And you can visit it, you can go and check it, how all these items are working, right? There are very good formulas, very good explanations, very good examples. Maybe not many related to the aviation, right? But about aviation, we're gonna, as I said, I'm planning to discuss in our maybe next chapters and in the future. Okay, and definitely when you're using all these items, when you're building the models, please always use engineering judgment. Don't forget about this. Don't ignore it. Thank you, and see you next time. Bye.